Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream. Today we're going to be diving into the parser library that I've written for my programming language. We're going to be changing the way the parser works a little, and we're going to eliminate expression left recursion. Now, what is expression left recursion, right? Let's draw a quick example, because at the moment this is a really big problem. The way parser combinators work, we have let's define a simple language and look at an example, right? So let's say an expression. If we define this as, that was a long equals sign, if we say an expression is either a literal, so like a number, let's say, or a function call, or an array ref, okay? Where an array ref is something that looks like this, right? It's something that's kind of like A4, right? And the way this kind of has to be defined in my language is that it's an expression, and then a square bracket, and then an expression, and then another square bracket, right? So we have a thing that is a child of expression. So within expression, we have array ref, and then the first child of that is itself an expression. So what happens when we try and parse this? Well, our parser combinator comes in, it looks at an expression, it tries to parse it as a literal, it fails. It tries to parse it as a function call, it fails. It tries to parse an array ref. So this is like step 0. So it comes in here, and then it sees expression. So when we try and parse an expression, we try and parse a literal, and it fails. We try and parse a character, and it fails. We try and parse an array ref, and so we jump into array ref. We try and parse this expression, now we come in. Is it a literal? No. Is it a call? No. Is it an array ref? And now we go in here again, and again, and again, and again, and again, and that is how we end up in an infinite loop. This is never going to terminate. So how can we rewrite our parser? How can we rewrite our rules to eliminate this left expression recursion? Expression left recursion. Now, I saw this thing, I read this article, and it kind of talked about this in a cool way. It told me that if I have a parser, and it looks like this, so we have a rule A, okay? And this rule A gives us, can either be A, alpha, or beta, right? So this is left recursive, because the first thing of one of the children is the parser itself. So, how can we rewrite this to be better? Well, the thing I read, and I'm sorry, I can't give a source. It was a very good article, and I've lost the link. But it gives the summary that, well, what different things can we parse with this? Okay, so if we get beta, it could be beta, right? That's a valid parse, and that's terminal. Or we could have something, resolving A followed by alpha. So that could be beta alpha, or it could be beta alpha alpha, or it could be beta alpha 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 ... They all have this kind of form. So what if we rewrite this so that it's something that starts with beta instead of something that is left recursive followed by alpha? That is the basic idea that's going to underpin our rewriting, okay? So in this case, I think we can rewrite this so that it's something like A is either beta or, no, what are we saying? It's either A is R. Do we say, wait, what's the recursive bit? So it's, let's say, I think we can say it's beta followed by R, where R is, that's not right, hold on. I missed something here. The idea is we're gonna rewrite it where this thing comes at the front. And the theory doesn't matter as much. I think I know how to do this in code. So we're gonna try and do this in code. Screw the theory. But this kind of idea of recognizing that it starts with a beta and that has a tail of things. So I'm gonna jump in now. Okay, we're halfway through writing a bunch of stuff, so I'm just going to git stash and check out main. I've done a bunch of work with the compiler. I'm going to swap my scene over, of course, because you want to see what I'm doing. That's why you wonderful people are here. I've done some work, some really big work on my assembler and a little bit of work on my language. They now both export much more sensible binary files. The way that all gets built is really good. The assembler now just does a lot more cool stuff. It's not finished yet, it's a bit buggy. So we're just gonna stash this and go back to the main branch. And I'm just gonna make sure we're up to date as well. Please don't sniff my super secret SSH key by the sound of my keyboard. Apparently someone can do that. Apparently that was a proof of concept attack someone made on a live streamer. So please don't take note of me pointing that out. I don't know why I mentioned it. I should rotate my keys now. Okay, so we're gonna make a new branch. We're gonna check out a branch. We're gonna call this branch probably something like left recursive expression, and we're gonna jump into our language. Okay, so let's find our expression functions. There's a whole bunch of them, and where's the big one? We have a binary operator. This kind of lives in the middle of nowhere. This file is really huge and should be split up. Okay, expression left-hand side. So I've kind of done this a little bit already, but not in a really satisfying way, because I've done it in a way that wasn't able to be generalized, right? I had this for binary operators, and then I had to copy this idea for array index, because on the left-hand side of an array index, you can have certain things, and these aren't the same, I don't think. Maybe they are. Maybe there shouldn't actually be two things here. It got messy. So we want to rewrite a new function, and this is my first goal today, one expression parse function, my first sub-goal within our main goal. We're going to write a function called expression. We're going to rewrite what is expression, right? Because currently expression is either a binary operation or a left-hand side. And there's so many weird, complicated reasons that I wrote it like this. So let's just write a new function that just handles an expression. It's going to give us back our favorite C result type, which stands for a result with a confidence, where our confidence is how sure we are that this specific thing was the cause of an error. So that's important when we have combinations where we select one of a list of things and they all fail. That's why we need this kind of confidence. So I'm just going to quickly audio check myself as well while I do this in the background. So what do we want here? Well, we probably want this same any collect error. We want this same idea, right? Where we parse all this stuff in an expression. Okay, so we try and parse a valid expression. So we'll say expression tail, let's say rest equals, any of these things, right? Any of these things. A literal, a struct field, a built-in, a function call, address or variable, something within brackets, a dereference, and these are literally the same, aren't they? I really got into a messy spot here. I really got into a very messy spot here. Okay, sorry, just sound checking. Perfect, okay, we're good, we're still live, we're still going, we're still kicking. I always like to do that before I start, but that's okay, I forgot. So, we've got this thing, we've got an expression, we've got the tail after that expression. We have to grab an expression. That is the bare minimum we have to do when we're parsing an expression. So then, what comes next, right? What is the alpha-y bit? What's the bit that comes after the thing that was recursive before? How do we take that away from the left-hand side? Well, we say, we're gonna have a function. It's gonna be something like expression handle, expression part array index, and we're gonna give it the rest. And we'll match on this, and we'll say that based on the result of this, if it's okay, e tail, then we want to make an array index somehow. Actually, do you know what's even better than trying to construct it here? If we pass in the existing expression. Now this moves this, so we probably actually can't return it later. What if I do it like that? What if I do a borrow? And then we can clone it. But I don't like the clone. Let's build it here. That's okay. So we have to make an array index expression object, and then we return. So let indexer and the tail, right? The thing that comes after this. Otherwise, if we have an error, we just kind of want to do nothing. We're like, okay, so you errored. That just means you're not an array index. Now there's a problem with this, and we'll get back to this, but if we error, we just say, okay, cool. No action, no comment. I have nothing to do. Then we need to do this again. We'll say the same thing for an expression part binary operator. If we get the rest of a binary operator, which will be a operator and an expression, so I guess we'll have an operator and a right-hand side. Let's call it right-hand side. Let binop, and then we're gonna return binop tail, right? So, and then we do the same thing here. If it's an error, we're just gonna ignore it. Cool. So then we just need to write these functions and build the stuff on the inside, which should be pretty simple. Hopefully. And then if we get to the end here, well, we've tried our absolute darndest to work out what could be after this expression, but I guess we just want to return the original expression. Okay. Oh yeah, this needs to be wrapped in an okay. That's why I've got these weird double brackets. I thought it looked weird. The expression and then the rest of the string. Beautiful. Beautiful. That seems pretty cool, right? This is nicer. This is much nicer. This means that we don't have to do this weird copy-paste stuff. I'm actually going to delete it right now. I don't want this anymore. This is the ugliest code I have ever written. Except I forgot to do this. So I should probably do this first. Should probably keep the most useful part of this. So let's do that. Yeah, nice. Because we have to keep the run because of reasons. Okay, cool. That's looking better now. That's looking a lot better now. So I think this will work. Once we write these remaining functions, I guess this will just magically work and we'll never have to think about it again. Which is cool. This left-hand side index, get out of here. Get out of here. We don't want you. We don't want this here. Left-hand side, yeah, we don't want this. Get out of here. Get out of here. I'm done. I'm done with you. Okay, so we're missing array index. So let's rewrite our array index function. Let's move it so that it's easier to see what we're doing. This is going to be pretty similar. And again, there's a problem with this. And if you're an experienced programming language builder, if you've built with parser combinators before, you might see the problem. And I'm going to leave it unresolved. I'm going to let it surface itself. And if at some point you realize that the way I'm using this result is not quite right, then that means that you're seeing into the future of what we're going to do. You might say, well, you know, why are you doing it this way if you know there's a problem? The answer is that I've never done this before, so I want to take it step by step. I want to start with the simplest thing and go from there. So we're going to call this expression part array index, and we're going to get rid of the first bit. So the first thing we grab is this token. Now all this skip white space stuff is going to go eventually as well, but for now, we just kind of have to live with it. So now, there's no more expression at the start, right? This is just part of an expression that comes after an existing expression. So this is cool. And the only thing we give back is, now it's no longer this, it's just the index expression. This is also cool, right? The only thing we want to give back is this index. Sorry, just have to time out a viewer and ban them for advertising cheap viewers. It's another day, another cheap viewer. Then we'll renumber these. Oops, I meant to press Control X because that is the shortcut to subtract one number in Vim. And then this is the input. This is S0, and this is S1. Okay, that looks good. That looks really good. So let's maybe, yeah, I'm happy with that. I'm happy with that. We need to do the same thing for the binary operator, and this is where it also gets like a second layer of messy, because we're still not doing operator precedence. Okay, operator precedence, it's pretty important. We'll get there one day, but maybe today is that day. It's on my list. I don't know, maybe that's ambitious, but we'll see. We'll see where we get. Expression part binop. Is that what I called it? Expression part binop. Okay, and this is going to give back a result, and it's a result with a string and a binop. I think an AST binop and an AST expression, right? Because previously we gave back a full expression binop. We would give back a full expression that was a binary operation, but now we're one expression short of a full binary operation. We need to give back the two parts, and we're going to construct it later. Cool, cool, cool. Okay. Oh, God. Nice chamomile tea. It's really hitting the spot. So, how do we parse a binary operator? I probably should have grabbed... Let me just like grab this whole function and move it up here, because I think that's nicer. So, what did we do? And we can probably do the same kind of thing as before, right? Except now we just skip a step. We skip the part where we actually grab the expression in the first place, because that's the part that's left recursive. And, you know, if it isn't clear why this was removing recursive left expressions, this is what we're doing. We're just getting rid of the first part. Even if I don't fully understand the theory of what I consumed, the idea was enough to get me here, because it's actually not that complicated. Well, I mean, it's not that complicated yet. That's probably the correct way of saying it. Okay, so we're going to have an expression, we're going to have an op, and we're going to have an expression. That's kind of it, right? That's everything. That's all we need to do. So we have a part binop. Now I imagine there's some cruft. Maybe? Maybe not. Array. Statement array index. That's fine. Okay. Maybe that's it. What happens if I build right now? It's a couple of errors. That's okay. First off, this is called bin op. Next up, oh yeah, well I forgot to actually like put the bits together. That's a bit of a problem. Expression array deref. This is what it is. Array. So it's an AST expression array deref. The left-hand side is the expression from the outside, and the index is the expression from the inside, and then we give that back. Similarly with the bin op, we want an AST expression bin op. Oh yeah, and these have to go in boxes. That's the only other thing, because otherwise you get a recursive type which has no compile time size. Dinkelman, welcome, welcome. You continue to have the best chat emoji. What is this? Where does this come from? I've asked you this before, but where does this wonderful character come from? Binops. This is just a tuple, I guess. Yeah, so we just have box new. We have the expression, we have the second expression, which is just called RHS, and then we have the op, which is just op. Cool. Okay, so now what if I build? Array index LHS. Okay, so we reused some of this for our statement parser. That's fun. I can click an emote and it'll give me the channel, a drop down with the channel that it's from. Okay. It's because I have to... Frog Museum. Frog Museum? What content? Is this frog content? No. No, it's just a cozy stream. I was excited for a second there that there was an actual like frog museum, but yeah, these are high quality. High quality. Mine is still a work in progress, unfortunately, because I have not given a good specification to my artist, and he has yet to commit. But we're getting there. It's been a very busy month. Okay, so it turns out I was using part of this expression parser for my statement parser, and this was an unforeseen wrinkle. Why was I doing this? Because, well, okay, isn't this just an expression? No, because only certain things can be on the left-hand side. I think this is an identifier, right? I think I actually want an identifier here. I'm gonna just say expression for now, and this does some kooky stuff, but we'll deal. Okay, so that works, which is good. Expected string slice. What type is this? Are you gonna tell me what type this is? Found expression, sorry. Okay, yes, rest. Rest. Expression, rest. Oh, did I just get these in the wrong order? I did. It gives you back the continuation first. E, yes, that's the same thing. E. Oops. I should have noticed that while I was writing the rest of my code. I noticed something felt imbalanced, but that is how it is. Yeah, so it gives back the T before, or the S before the T, the state before the T. Indexer, yes, this is the same problem. This is exactly the same problem. I like a channel described as variety gaming with a lot of chaos. That is a good combination of things. These errors are unused, which means I have to underscore them. Okay, now what happens when you run the tests? This is certainly going to fail. And this fails because stuff is just... Whoa. Whoa, where did this come from? What? 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 Oh no. Okay, hold on. This test shouldn't exist. That should have been committed, or at least stashed as part of my last stash. That got spicy. Okay, so what have we got here? Not used, that's fine. Generate a warning, that's all good. Now we get errors. Expression bin op, expression bin op, expression bin op. That's pretty easy actually. We're going to replace this just with expression, and that'll do. It's no longer a special function. If you want to test a binary operation, you just have to use a normal sensible function like anyone else. Okay, test array index. Test array index has blown up because it has ceased to parse a statement before it should have, right? So if we look at test array index, test array index, it's this. This is the test that failed. So when we try and parse a statement, for some reason, when it reaches the end of this, it's like, hey, whoa, there should be a semicolon here. And that's kind of weird. So let's test this again. Okay, so at this position, it's like, hey, there should be a semicolon here. Let's look at our statement function. Array index. So yeah, statement array index. Okay. Haha, this is good. This is good. Our expression now picks up an entire thing. So maybe this should actually just be an identifier. What if I say identifier here? Right, because then we don't try and consume an entire thing twice. Okay. Expected confidence hour found parser error. We can do that. We can do it with that. Map error. Confidence error. elevate. Let's just do this, even though that's not right for now. We have to do it sooner. Yeah, we can do it like this, with confidence. Identifier. And then we can say confidence low, because we're not very confident. That's the correct way to do it. That's the non-shortcut way. I need to stop taking shortcuts. Expected expression found identifier. Okay, now this is good. This is good because in the AST, we have an expression that is a variable. So we want, this would just be an expression variable, and inside it would be a vec with our LHS. Perfect. Perfect. And this should be the LHS. Cool. So what if I test now? Okay, that's closer. That has gotten to a different test. What has this gotten to? This has gotten to here? Because it's not an expression on the left-hand side anymore. Of course, right? We just told it it's not an expression. Okay. So, how do we do this? It turns out that the statement parser really depended on being able to parse a thing that could be the left-hand side of an array deref. Because some things don't make sense here. A function call... I guess a function call can make sense, right? It just changes how it resolves. Well, but we resolve all this stuff anyway. What happens when this compiles, though? Codegen. Block array deref. Expression array deref. We get the type. As long as it's not a pointer. The type of a function is the type of resolving the function. We turn it into a deref. What happens when we deref, just in general? It's not a pointer. We compile the expression. Yeah, okay, so I guess you could have a function. So that's kind of okay. So this idea of thing followed by square brackets, right? This, it's not an expression parser, but it is. It's an expression parser with everything except the square brackets. Ugh. It's almost like what I had before was actually stupidly right. How can I make this work? How can I make this simple and say, hey, expression? I guess I could look at the result, right? So if we look at statement array index, what if instead of this, I grab an expression, okay? But then I say, I don't do this bit. I get rid of the bit where I grab it as an array index, and I say if matches, so if S0 is an AST expression array deref, or I guess if it isn't an array deref, then we want to return an error that says, what are my errors? Parser error. Expected array? No? Yeah, I guess. Expected array deref. This is parse error new. We take the input as a context so that we can print out where that's occurred, and the parse error kind is parse error kind array deref expected. Expected So what does this look like if we build it? Now there's probably something wrong here, right? Oh yeah, all the variables that no longer exist. So 1, 2, 3. This is now simpler, which is cool. 1, 2. The index is no longer found. That's because we actually need to destruct this into its parts, right? So we've parsed we've parsed this into its base element. So we probably want to say if let ast expression array deref. Now what are the fields for this called in this? Array deref LHS and index. LHS index equals s0. So we'll do this in the positive instead, and then down here we'll have an else. Cool. So if this is an array deref, then we want to keep going. And not s0, sorry, LHS. Then we want to keep going. Then we want to get the thing that it assigns from. And this is where we actually build the final statement. We remap the stuff. Expected expression found box expression. We can fix that. We can just put a star there, right? Yeah, LHS, LHS. I think index is going to need the same thing. Unbox it. Expected confidence error found a parse error. Now, what confidence is this? This is probably confidence low, right? Because we're like, I don't know. With confidence error from, so say confidence error from this with confidence low. Okay, that's better, that's better. Self, match self, error, expected array deref, we can deal with this. This should be so low confidence that we never see it, but we should track it with its own kind just in case. And if we ever see it, it's probably a problem. Okay, now it's gonna work. And it gets to, okay, it gets further. That's good news. That's good news. We're still done a little bit too early. Every time we just seem to get a little bit further through this thing. So that's good, right? That makes me feel good about what's happening here. So this really crazy example, right? What's going wrong here? We consume the whole thing, but we seem to kind of be done afterwards, which is weird. So we're running a statement parser. That's good. That's good. What's the intermediate step? How is this? Why does this think it's done? It's likely because of the nesting, right? It's likely because of the nesting. Because this is going to be looking for an expression. Okay, I think what actually will make this easier to see for now. The thing is, I think this might succeed. No, it's after this. It's here. It's like it wants a semicolon like in here, right? So if you look at it, it's saying that it finds this, but it's looking for a semicolon. Why is it looking for a semicolon? Why is it after? Why does it think it's done here? S3, this is the thing down here, 0, 1, 2, 3, yeah. So that kind of seems okay. And if this error was getting thrown up, it wouldn't come out halfway through that string, right? It wouldn't consume anything. Unless there's a different statement that is coming out first, and that is possible. Array index if while variable assign, assign declare no value, continue break. So it could be falling through to this. It could be. There's a really dumb way to see if that's happening. And I'm not, let history know. I'm never a man who was afraid of doing the dumb thing. So we're just going to put a panic in here. And if this branch is ever triggered, then we'll know. Oh boy, we'll know. Okay, that actually failed a whole bunch of things. Of course it did. Of course it did. Most things are in fact not array indexes. Test array index. Test array index. Panicked. It panicked in the same spot. Did it? But it panicked here because it expected this thing. So it actually did not hit that branch. Did not hit that branch, right? Didn't change the error. That's what we want to see. It didn't actually change the error. So that means that somehow in calling expression... No, but that doesn't make sense either. How does it ever try and look for a semicolon? The only place it'll ever look for a semicolon is as part of a statement. Zero, 1, 2, 0, 0, 1, 1, 2, 2, 3, 3. So that's correct. That is correct. I'm gonna do the other dumb thing that is really fun. Try to look for colon equals. We'll just see if we can follow where we are. I need to stop pressing Ctrl Z. That's not how I do this. Okay. Looking for a second expression. But we never hit... So looking for a second expression is where this blows up. We never actually hit this. So that's interesting. That's very interesting. But the point where we die is... So the right-hand side. The right-hand side. Unless these run in parallel and these prints are actually not useful, it looks like this is good, right? So it looks for a colon equals, looks for a second, blah, blah. So this one's done, this succeeds. This one's done, this succeeds. And then we start looking for a second expression, but somehow we haven't actually consumed this colon equals. How's that happened? How has that happened? That makes me feel like I just haven't done this bit properly, right? Right? Because we shouldn't get here with S1 if we aren't there. This feels like bad state juggling. This feels a lot like bad state juggling. Okay, so test array index. I'm gonna just do the dumb thing for a sec. Again, we're doing things the dumb way. There are better ways of doing all of this, but we're just gonna keep going the dumb way. The other interesting thing, I guess, actually, do you know what would be even better? Just in the println, I put whatever current state we're up to. So I say LHS index, right? And then here I say LHS S0, S1. And then we just know what is kind of triggering this. Let's say LHS, RHS, S2. And we're not control Zing, we're make T'ing within Vim. So a equals 5, blah, blah, blah. So this is a more complicated example. We can see the left-hand side, we can see the index, and we can see the rest of the thing we're looking for is this. We're looking for a second expression here. But the context is kind of rewound. The context gets kind of rewound here, right? Because S2 doesn't have this. So how do we ever go back to the state in S1? Right? There's got to be something really obvious here that I'm just missing. But no, because we don't panic. Of course we don't panic. So it's just weird that we ever print that we're looking for a second expression to then fail that check, right? So what happens if this fails? Well, if this fails, we bubble back up to statement, the main statement function. We look for an if, which we don't find. We look for a while, which we don't find. An assignment deref, which we don't find. So all of this, unless we look for an expression. Okay. That makes sense now. That makes a lot of sense now. So the error is actually coming from this parser, right? Statement array index is failing, and then we're trying to parse it as an expression. What are we trying to parse as an expression? It's this test. This test, right? So we parse this thing. Yep, we parse this thing. We find the colon equals, and then when we try and parse this as an expression, it blows up on me. Now, then when this fails, we go back to all of this. And one of the things we try and do is parse it as parse an expression, which we do from here, but we expect a semicolon afterwards. And there isn't a semicolon afterwards because that's not what this is. So we can deal with this. We need to deal with this by making sure that the array index error, if it gets this far at all, we need this to be high confidence. This isn't just medium confidence anymore. This is high confidence. So what do? We look for confidence error, elevate self. Okay, so we want high. So this is a confidence error. What's a good API for elevating this to high? What's in combinator? What's it called? Confident. Nope, not in there. With confidence, I guess. So we could say with confidence, this whole parser, and then we move this down to here, and we would say confidence high. Okay, debug printing to the rescue, as always. high confidence. S2, we're gonna delete to there, that's a little better. So what if I build this now? It's probably gonna yell at me about something. Expected a confidence error, found. Oh, but now I've got a confidence error of confidence error. Hold on, that's still not right. That's still not right. That's just annoying. That's really just annoying. I need a function that does this. So I want a function that t. Let's just make some functions to do this. Let's make a function called toLow, which is going to take a self and give us back a self, and it will be a self. We move the t and we say confidence is confidence low. Let's actually maybe just do it like this. This is less typing right now, less bloat, right? So we move ourself, we take a confidence. Oh, but it's nice if you can do it without it. Okay, no, I'm gonna do it like this. It's nice if you can do it without having to write a thing in the lambda. You can just do it kind of like freehand like this. So we'll say to high, right? A method that operates, or a function that just takes one argument. It's a better API. I think it's a better API. I don't like having lots of different ways of doing the same thing, but it's a better API. Okay, here we go. Expected token star. Now that's unexpected. That's very unexpected, in fact. I don't think anything has ever been more unexpected than this. Like what? Huh? What? Context here. So this is good. This is actually what's gone wrong. But how has this... What does this expect? So, excuse me? Hello? Okay, so we need to add a test case just for this right-hand side, apparently. That's kind of crazy. I think this goes in test X for brackets, maybe, or just test... Where's my test bonkers expressions? Where's my test unhinged nonsense? Let's just put it in test. Well, I guess it's our binary operator test, right? Which looks quite lacking, actually. Okay, well, let's make a binary operator test. Cool, okay, so we're gonna try parsing this as an expression in my favorite little unit test format. Nice, so of course this one fails, and it fails with the same error, which is good, but I'm still not totally sure why. Because the bracketed ones pass. Brackets pass, that's good. Array index within brackets should be good. So what if I get rid of the brackets around this? Does this work? Can I actually nest these? Can I chain these, rather? No. No, I can't. Because it just stops parsing. Of course it does. Of course it does. Because it just looks for one expression. Okay, no, that's fine. That's fine. What about this? What about this? binops. That passes now when it's inside the thing, but when it's so what if I get rid of the array ref within here? Does that also pass? Yes. Yes, it does. So this is a very mysterious error. This is very, very mysterious. And for the time, the nesting is actually really interesting to test. Or not even nesting, but you know, why does it look for a star? So this is basically a test that is too hard for my parser right now, but I should copy and paste it and say, okay, this breaks. Like I've got a test that I know breaks my stuff, but I don't actually have the tools to debug said test yet. I need better error information in order to do that. Cool, but that's nice. Let's actually write some binary operator tests though, because that's kind of important. 10 plus 101 plus a. Now this is hard because, okay, that doesn't fail. That I wasn't sure if this would just kind of stop here, but I guess it keeps going because binary operator has higher precedence, which is good. We need to do that. We need to continue to consume binary operators in a chain. That's one expression. We'll get to associativity, but that's a whole other kettle of fish. Now, minus a 12 plus. What else haven't I done? Foo plus foo bar. Now this is interesting. The priority within expression is a little bit messed up. I think I should always try to do binary operator before array index. I think currently I try and do array index first, so sometimes I'm gonna eagerly determine that I've finished when that's actually not the case. Expression. Okay, so yeah, okay, so I think this just needs to come first. That should fix that. But maybe it won't. But maybe it will. We're gonna find out. No. But that's also mysterious because, well, I guess it goes, it tries to pass a binary operator with the rest. But the rest in this instance, starts with here. So it tries to pass this as a binary operator, so of course it fails. So it tries to pass this, and it succeeds, and then it's like, cool, we're done. That's it. So what it actually needs to do is then try to look for further binary operators, which I guess we can do. How do we do that? How do we make sure that we always try looking for a binary operator after? I guess what we have to do is say, this is going to be, so actually let's put this first again, okay? We're going to make rest mutable, okay? Now, this is what we do. This is what we do. We don't, do we return here? Wait, no, but we can't have, crap. No, wait, we can do this. Let's make this mutable too. Okay, so if we get here, then we say our expression equals this and our rest equals tail, right? So then we either try and do the bin op or return. I think this actually works now, as long as it compiles. Yeah, cool. So what did I change, right? It was a very subtle change. I changed this so that even if we find an array index, we keep going and try and look for a chain of binary operations as well. So what that means is an array index can be part of a chain of binary operations. And actually, that fixes our original error too. oh boy, does that fix our original error. So let's find our to-do. This fixes this. This is now fixed. This now works. All our tests pass. Beautiful. So let's actually get rid of the easy version of that test. And that was why. It was hitting this, it was trying to do it, and then it was like, I don't know, what do I do after this? You can't have something, you can't have a binary operation on the right-hand side of that, you madman. So that's cool. I might cut the stream there, because we've had a few good wins, okay? We've eliminated expression left recursion. We've done it. It's checked. It's about to get checked off. So we have one expression parse function. We no longer have array index recursion. This should be negative, but that's okay. We no longer have binary operation recursion. We're done. We have eliminated left recursion. The next goal is binary operation precedence. And that is going to be a whole kettle of fish. That's going to be a very fun stream, okay? How do we do binary operation precedence? I don't really know. I found a really good article that talked an algorithm through that isn't like Pratt's algorithm, or I don't know if Pratt's algorithm even works for parser combinators. But I found a really, really good article, and then I accidentally closed the tab on my phone and I didn't notice, and it's not in my history, and I have not been able to find it again. So it's one of those fun articles. It's gone. It is gone. We'll see if I can find it again. Otherwise I might just wing it. I kind of remember what it said, so maybe I'll half make it up. So thank you everyone for tuning in. This has been a productive little stream. I love when I can start a stream with a goal and check off a bunch of boxes, and it kind of works, because this stuff, while complicated, actually isn't extremely challenging, you know? It's hard to do correctly. It's hard to wrap your head around, but I've been thinking about this on the tram all day, just going back and forward between different things. So I was really excited to sit down and smash it out. Thank you very much for tuning in. Thank you to the people that stopped by. I'm Tom, and I will catch you next time.